Hey Becca, what are we learning today?
Today, we're going to convert from radians to degrees. Converting from radians to degrees, we're going to have a conversion factor very similar to the conversion factor we use when converting from degrees to radians. So we know that pi radians is halfway around the circle. Pi radians will take us halfway, and that's also 180 degrees. And our conversion factor for going from degrees to radians was pi over 180, since pi and 180 degrees are equivalent. So now our conversion factor from going from radians to degrees is just going to be the reciprocal of this conversion factor. So it's going to be 180 degrees over pi radians. You're going to multiply by this term, and the original term is a radians, which will cancel with the denominator, and your remaining unit will be degrees. I wrote our conversion factor, 180 over pi, at the top of the board so that we can use it for reference in the next two examples. So on the left side, I have two measurements in radians, and we're going to convert them to degrees. So we'll start with 2 pi, and we have to multiply this term by 180 degrees over pi radians. Now we can cancel the pi's. We're just left with 2 times 180, and we get 360 degrees, which we know is 1 revolution around the unit circle. So 1 revolution, 2 pi is equivalent to 360 degrees. Now let's try converting pi over 3 into degrees. Multiply by 180 over pi. With a little reducing, the pi's can cancel, and both these terms are divisible by 3. And 180 divided by 3 is just 60. So our answer is 60 degrees, which is equivalent to pi over 3 radians. Here are 2 more examples of radians that we can convert to degrees by multiplying by the conversion factor. 5 pi over 4 times 180 over pi. In this case, the pi's are going to cancel, and we can reduce the 4 and the 180. Both are divisible by 2. 180 divided by 2 is 90. And we can reduce this by 2 again. This becomes a 1, and 90 divided by 2 is 45. So our last step is to multiply 5 times 45, and we get 225 degrees. And that's equivalent to 5 pi over 4 radians. Now let's try 2 pi over 3. Multiply by the conversion factor, 180 over pi. We can cancel the pi on the bottom with the pi on the top. And the 3 on the bottom, 180 divided by 3 is 60. So our answer, 60 times 2, 120 degrees. And if you were drawing the unit circle, we can put both of these measurements on the unit circle. 2 pi over 3 comes before pi, so we can put 2 pi over 3, that right here, and that's also 120 degrees. 5 pi over 4 is past pi, so it's about here. 5 pi over 4, which is equivalent to 225 degrees. My last example is a negative value that's not a common value on the unit circle, but we can still calculate the degree equivalent to this value. It just might not be a reducible fraction. So we have negative pi over 7. If we multiply this by the conversion factor, 180 over pi, the only thing that can cancel here are the pi's. 180 is not divisible by 7, so if we were to write this in degrees, it would be 180 over 7 degrees. But we can plug this into our calculator to get a more accurate answer, and it comes to negative 25.71 degrees, which would fall on our unit circle. If we're going around, negative means we're going clockwise rather than counterclockwise. Negative 25 degrees would fall about here. And that is equivalent to negative pi over 7 radians. After watching this video and my previous video, you should feel more confident in converting between radians and degrees, or degrees and radians. If you have any questions, make sure you leave them in the comments or send me an email. And if you subscribe, you'll see all of my new videos every Monday and Thursday as soon as they come out. Have a great day!